For this video, let's try to come up with the reflection of negative 2 and 4 about the angle of 60 degrees. First, let's try to plot this on our Cartesian plane and later on also illustrate the line that will represent the angle 60 degrees counterclockwise, of course, just like in a unit circle. So negative 2 and 4 is actually here, negative 2, and then you have here 4. So our point is somewhere here. Okay, that's our point. So let's try to look into its line. So this is again negative 2 and then 4. So to determine the line for 60 degrees, of course, you're just going to assume it here. Hopefully that my assumption is correct. More or less, it looks like this for 60 degrees. So let's assume that I don't have a protector here to try. Let's assume that this is really 60 degrees. That's our theta. So we're going to take the reflection of negative 2 and 4. So probably the reflection is somewhere here, right? Because as we reflect it on the line. So similarly, it's just still a reflection, but the process here would involve a certain angle. The formula intended for us to determine that is in this manner. The reflection of your point X along the line of your angle is identified as the product of matrices cosine 2 theta, sine 2 theta, sine 2 theta minus cosine 2 theta, and the components of your x, which is x sub 1 and x sub 2. For this would be our x sub 1, this would be our x sub 2. Take note that the result for this is actually defined because you have here a 2 by 2 matrix times 2 by 1 would result to still a 2 by 1 matrix, which would stand for a point. So let's try to apply the formula now. We know that our theta is now 60 degrees and our x, let's just simply use x, negative 2 and then 4. So this would mean the result here, or the matrix, will become twice 60 degrees, sine twice 60 degrees, sine twice 60 degrees, minus cosine twice 60 degrees, to be multiplied with the components negative 2 and 4. Take note that our prediction is that its reflection would be on the first quadrant, so we were expecting answers in negative values. So simply continue this. Let's start to simplify first the matrix with angle or trigonometric ratio so that we could actually come up with a scalar value later on. So this is actually cosine of 120 degrees, sine of 120 degrees, sine of 120 degrees, minus cosine of 120 degrees to be multiplied with negative 2 and 4. Now, just remember what would be, by the way, this is not equal to x, right? It's actually equal to, just to be not to be confused, this is the formula for that. Okay. Now, just remember the special angle. What is cosine 120 degrees? It's actually in the second quadrant. The cosine for that is actually equal to 1/2. The sine of 120 degrees is square root of, it's negative 1/2 because the cosine of 120 degrees is somewhere here. So the negative is, cosine is negative. So the sine is positive square root of 3 over 2. You have here square root of 3 over 2 and the negative of negative 1/2. You have here negative 2 and then 4. Okay, so you will have here the final negative 1/2, positive square root of 3 over 2, positive square root of 3 over 2, and positive 1/2 now to be multiplied with negative 2 and 4. Take note that if you're going to multiply that, always remember the correct process of multiplying matrices. So it would be a 2 by 1 matrix as mentioned. It's actually, let me increase this size here. So it's negative 1/2 times 2. Can we just simply try to allow me to automatically provide the result for every term being multiplied? Negative 1/2 times negative 2 is positive 1, plus you have your square root of 3 times 4. It's actually square root of 3 over 2 times 4, so that's actually by 2. Okay, sige, allow me to write step by step here. Negative 1/2 times negative 2 plus square root of 3 over 2 times 4. Okay, so you have the other one is square root of 3 over 2 times negative 2 plus 1/2 times 4. Now the result for this would be our point. So that's actually positive 1 plus 2 square root of 3 and the other one here is negative square root of 3. This should be 1/2, sorry, this should be 1/2 plus 2. Okay, so in short, its reflection along the line for 60 degrees is actually the point 1 plus 2 square root of 3 and negative square root of 3 plus 2. Let's find out if we're going to try a values in decimal notation if it's really on the first quadrant. So 1 plus 2 square root of 3 is actually approximately in 2 decimal places. Allow me to approximate this in 2 decimal places. You will have your 4.46, and for the second one, negative square root of 3 plus 2, approximately 0.27. As we have a proof that it's actually in the first quadrant. Let's try to plot this 4.46 here, and let's find out if we can actually look for the final, the correct reflection. So 1, 2, 3, 4, 4.46 somewhere 4.5, and you will have your 0.27 is very small, so somewhere here, just 1/4, almost 1/4. This is the point, okay, and if you're going to connect them, they must be perpendicular, right? Or it would form a perpendicular segment, because we'll have here a symmetric symmetry of the image. So the point is somewhere here, which is actually equal to 1 plus 2 square root of 3 and negative square root of 3 over 2. Okay, so this is the reflection of negative 2 and 4 about the angle 60 degrees. Thank you very much for watching.